Hello.
Yeah, just we have started. Can wait for a few minutes. I'm going to start this. We have not yet started this session. Can wait for a few minutes.
Oh, yes.
Oh.
Thanks. Thanks.
We are waiting for everyone to join. We'll start the session in a few minutes.
Okay, sir.
Okay, let us start the session. Start the recording. Yeah. Okay. So today, we are going to see about Snowflake basics. We are going to see why we need data warehouse, why we need Snowflake, and how we can learn Snowflake. So in the course, what are the things we are going to learn? So we are going to understand the basic one here. Okay, so in the course, I'll be using different tools. Okay, so I'll be using different tools. For the installation, I'll explain you in the next session. In the next week, we'll see about what are the tools are required in local, like Visual Studio for IDE, and we use dviewer, like different tools. I'll explain about the tools which are required. Today, what we are going to see is why data warehouse and what we are going to do with data warehouse, the core goals of data warehouse, what is Snowflake, and in Snowflake, like what we do, what is ELT, ETL, and in cloud, why we need cloud. So we have to use AWS and Azure. We are going to see both. So why we need cloud and why we need data lake and data platform and how you can use Snowflake. Free trial, how you use free trial version. So these are the things we are going to cover today in the today's session. If you have any questions, you can message in the chat. So if it is relevant to the current discussion, I'll explain it immediately. Or if something it is not relevant to the current one, we will discuss at the last 15 minutes. So you can ask all your questions in the last 15 minutes where we'll have a Q&A. Okay, so first, why we need data warehouse? Why we need data warehouse? So what is the need of data warehouse in an enterprise? So I'm working for a bigger organization. So I need to know, so what is the purpose of data warehouse? So before starting into the technicals, so in this course, so this is a more of a bootcamp based where we are going to cover lot of hands-on, right? So we are going to do lot of hands-on. Okay, so you need to practice whatever I'm going to teach it. You need to practice. So if you don't practice, you are not going to get experience from that. So we are practical implementation. We are data pipelines. We are going to work on different real-time scenarios. So it's like a bootcamp way of, like the course is designed in a way of bootcamp. Okay, it's not a normal Snowflake training. Okay, so normal Snowflake training where they discuss theoretically, they understand lot of concept, they go through a lot of conceptual way of doing, and they discuss about syntax, they discuss about a lot of basic concepts. Okay, so we're not going to discuss a lot about concept. For that, you have to practice, you have to understand a lot of things on your own. Okay, because why? Because we are going to do practical implementation, we are going to see real-time implementations, a lot of real-world problems. We are going to understand real-world problems. So the training here are designed in a such a way that when you get into corporate, how corporate training would be. Okay, so it's a job focused base of training here. Okay, so you will also learn basics, but it is going to be faster. When we are going to learn on concepts, when you are going to learn on basics, we are going to go in faster mode. Then we will learn a lot of problems, real world scenarios. So that is how the course will be. Okay, so it's a fast pace learning program here. Okay, it's a fast pace learning program. So you will understand real world problems, you will get experience, and I will share my like architectural knowledge, like lot of production issues. So I'm going to share a lot of knowledge, real-time knowledge also in the course. Okay, so this is how the program is going to be. This is how the sessions are going to be. So you need to practice. So if you are not practicing, if you're just watching the videos, you may not understand later stage of time. So when we get into projects, we are going to work on two projects. So when you are getting into project, if you don't understand basics, it will be difficult for you to work on the projects. So each sessions are related to each other. So when we work on projects, we would have done a lot of things in the previous sessions. So if you don't have a basic, then working on a project will become difficult. So that is why you need to go through one session and practice it day by day. Okay, so as we are having weekend program, so you need to practice in the weekdays, or you can in the practice in the evening sessions. So you can practice it and you can ask me questions in the weekdays also. I'll help you. You can ask me questions in the WhatsApp. So you can reach me out in WhatsApp. You can ask me questions. Okay, fine. So let us get into the session. So first, when we are starting with data warehouse, so we need to understand what is legacy data warehouses, right? So what is legacy warehouse? So I'm going to use Notion. So where your contents will be there. You can see the contents are going to be in Notion. I'm going to share Notion link later where you can see the contents. Okay, so first, what is a data warehouse? So what is a data warehouse? So this is a legacy warehouse architecture. It's a legacy warehouse architecture. So I am working for a banking, I'm working for an e-commerce organization, or I'm working for an insurance organization. So in enterprise, they have different teams. Okay, so they have different teams, they have different business group. They use different kind of applications. So you collect the data from all these applications, bring it to a centralized system, and you do analytics. So that is what data warehouse is about. The core purpose of data warehouse is to collect the data, bring it to a centralized layer, and maintain the data in different forms. Raw data, aggregated data. You are maintaining the data in different forms so that it can be used for different purposes. Like visualization, it can be used for different analytical purposes. So in the legacy system, you have to collect the data, bring it to your data warehouse, and then you are going to use for analytical purpose. So you can bring the data directly to data warehouse, or you can do ETL, you can do transformation and bring the data. So that means we can load the data directly into data warehouse or transform and load to data. So in your old systems, like old systems, let us go in 90s or in 2010, Teradata, SQL Server. So there are different data warehouse tools. There are different data warehouse tools which was running in on-premises. There are physical servers. The advantages, the advantage of the systems are they had strong consistency. They are in on-premises, so they are secured. Okay, so advantage of legacy data warehouse system. They are in on-premises, so are secure, and they are suitable for structured scenario. And the problem, as you can see the problem here, they are difficult to scale. Scalability is the biggest problem. Scalability is the biggest problem. And the other thing is hardware license cost is again expensive. The data warehouse is expensive. So companies, when they data grows, when the large volume of data they have to maintain, they have to pay a lot of money for license cost. They have to pay money for scalability. So that is the problem, and slow performance. Okay, so in legacy data warehouse, So we are talking about an enterprise who is operating in different region across the globe. They have large volume of data. They have multiple users, different devices, different applications. So their data is going to grow enormously. And initially, they had only analytics BA tools, but later they had machine learning, they had AI application use cases. So they are building a lot of data solutions, data products. So your legacy data warehouse cannot be used for all the scenarios because scalability is the biggest problem and license cost. It cannot be used for a lot of things. Performance is slower. So that is where modern data warehouse came in. So modern data warehouse are like a Snowflake, BigQuery, Redshift, Synapse Analytics. So your modern data warehouse are built on top of cloud. Okay, so you need to understand a little bit on cloud. So you need to have knowledge on cloud. So when you work on Snowflake, when you work on the modern data warehouse, like data houses, so you should have knowledge on cloud. So either it can be AWS or Azure or GCP because it's built on top of cloud. So you need to have basic knowledge on cloud. A little bit on the cloud, how it is functioning, why we need cloud, so how the data are getting stored. So you need to understand it when you work on the modern data warehouse. So what are the advantage of modern data warehouse? You can easily scale it up and scale it down. Okay, it's cloud native and scalability is there. So with the modern data warehouse, it's highly scalable. You can use it for batch processing, streaming, real-time analytics, and you can store different type of data, and it's a pay-as-you-go model. So here, here you are going to go for higher license fee. It's like 5 years license, 1 year license. So you are going to go for like that. Here it's you are going for pay-as-you-go model. So if I don't want, I can easily bring down my cluster, bring down my scale down my missions. So here it's flexible. You have a lot of flexibility as you are working on cloud. So you have a lot of flexibility on the pricing, on the increasing your size, scaling up or scaling down. So you have a lot of, you can use it for different purpose. You can use it for analytics, ML use cases, a lot of data products you can build. Okay, you can have a simple small instance or you can go for a larger instance. So like that I can scale it up based on my need. Okay, so here the challenges are data security, vendor lock-in. That means you are working on a cloud, your data is on the cloud. So you need to have your data securely. So that is the challenge. So that you can solve it. You have challenges, but you can solve it. So and then when you work on the cloud, you are moving the data into cloud. So that are the problems in modern data warehouse, but we can solve some of the problems. But for organization, this become a cheaper solution. Why? Because your organization, they are working on multiple business problem. They have multiple business problem. So they have different business group. Okay, so let us take e-commerce organization or there's a company who is selling a product online. So they have website where customers can order. They can order products on the online. They have a sales team using CRM tools. They have products which is coming from production. They have warehouse where the deliveries are made. That means the from warehouse logistics are done. So they have different teams. They have sales team, marketing team, logistics team, finance team. Like that, they have different teams, and they need one product where all data can be stored because all these teams use different kind of applications. Okay, so each teams has their own application. For example, CRM uses Salesforce. Salesforce is a product, SaaS product, which is popular for customer relationship. So your customer CRM team, sales team uses Salesforce. Your ERP team uses SAP. They are using some ERP solutions, Oracle systems. Your logistics team uses different product, IBM product or Microsoft product. So each team uses different kind of product. So that product has lot of data. Okay, so they have lot of data. So all this data has to be collected and brought into a centralized place so that I can do intelligence. Okay, so if the data is stored in individual systems, we call it as data silos. That means the data are separated out because you are working in an organization. The data should be the data should be available in a centralized place. Okay, the data should be available in a centralized place. So I can use for different analytical purpose. It can be for dashboard, it can be for reporting, or ML use cases or generative AI use cases. So if the data is in centralized place, I can use it for different sources. So I have to collect the data from all the systems. So this all the systems are data sources. So all the systems are called data sources. Collecting the data from this sources and storing it and then using it for analytics. So that is what we are doing it in data warehouse. The core capability of data warehouses. So let us see the core capability. So centralizing data from multiple sources, cleaning the data. So cleaning the data, transforming and structuring the data for analysis. Okay, these are the core capabilities of your data warehouse. So you are getting the data from multiple sources. So it can be from ERP systems, it can be from REST API system or database, or from different third-party systems or a SaaS product. You are collecting the data from various systems, bringing to a centralized place and transforming, cleaning and transforming and structuring it for your various needs. Okay, so that is what you are doing in data warehouse. And also, you are having some historical data, you are having current data. Your data warehouse is highly scalable. So you can have historical data, you can have current data. So you can use it for various analytical purpose. Okay, so in data warehouse, these are the core capabilities. So we have multiple components in your data warehouse. What are the components? Ingestion, staging layer, transformation layer, modeling layer, data mart, semantic layer, analytical layer. Like that, we have different layer. Why this different layer? Because when you are working on data warehouse, the data comes from ingestion, the data are transformed and data are modeled. So the data goes through each of this layer. Data goes through each of this layer and it is stored and then it's used for various purpose. Okay, if you see a data warehouse architecture, you will see all these layers: ingestion, staging, transformation, modeling, data mart, and semantic layer. So we are going to see all this layer in detail. So we are going to go into ingestion detailing, staging layer, transformation layer, modeling layer, data marts. Like we are going to see all this layer. Okay. So and in data warehouse, we are going to do we are going to use all this component. Okay, so we are going to load the data from sources. So I'm going to connect to database like a OLTP system like MySQL. I'm going to collect the data, bring it to your data warehouse, and then I'm going to use it for analytics. So you are going to use different component in your data warehouse. And in your data warehouse, what are the key things we do? So we work on data modeling. So we build fact tables, dimension tables. We work on the data modeling, and we work on like when you compare your data warehouse with your database, there are a lot of advantages are there in your data warehouse. Okay, because it's used for enterprise purpose, there are a lot of advantage which you have it in your data warehouse. So you need to understand like my database is not scalable. Okay, I cannot store large volume of data. So you cannot use it for historical data. So you cannot store historical data. But your data warehouse is can store historical data. You can do updates as we do it in database. You can do updates. You can maintain historical data. Versioning you can do. You can maintain old data, new data. You can maintain different copies of data. So we will discuss about different concepts like slowly changing dimensions, how you do updates, how you do time travel, versioning, incremental loads, full load, governance, how you do data governance, metadata management. So we are going to discuss about all the data warehouse concept. So in the organization, the core purpose of data warehouse is to storing the data and providing consumers different options so that they can do versioning, they can do data sharing, they can do updates, they can do data governance better. So in your data warehouse, you can do all this thing. Okay. So that is the core purpose of your data warehouse. Okay. So in your organization, when you're working for organization, you are going to have multiple sources. You are going to collect the data from sources. That is called ingestion. You are going to collect the data collect the data from the sources called ingestion, and you are bringing into Snowflake. So this is the Snowflake architecture. This is the Snowflake architecture. So we have discussed about legacy architecture. So this is the legacy architecture. So in a legacy architecture, there were multiple tools were being used. Okay, so there are multiple tools. So I need to get multiple tool license. So for ETL, I have to go for Talent. I have to use Talent or Informatica or Pentago. For reporting, I need to use different tools. For data warehouse, I need to get SQL Server or Oracle license. So in a legacy system, they need to get multiple license. They need to multiple teams to manage. So they had a bigger teams for managing the data warehouse. With your Snowflake, you are going to have centralized team, and you are going to get one license or few license. You are going to reduce the license, and you can do everything here on one unified data platform. So on one unified platform, you can do all the thing you did it on legacy warehouse, and also it's highly scalable, and it is like it can be used for different consumers. So that is the advantage of. So that is the advantage of your Snowflake architecture. Okay, so far we have started with what is data warehouse. Okay, so what is data warehouse? So the core capability of data warehouse, that is what you have seen so far. So and your Snowflake is a cloud-based data warehouse system. So what is a Snowflake? It's a cloud-based data warehouse system. So what it is, cloud-based data platform. So you can see here, Snowflake is not only a data warehouse, right? It's a data platform. It's a data platform. You can use Snowflake for data warehousing, you can use for analytics, data collaboration, machine learning, you can use it for different purpose. So in organizations, when they are going to work, they have different kind of like batch processing. So let us say batch processing, REST APIs, streaming. Okay, so what is batch processing? What is streaming? What is REST API? Okay, let us understand this. So let us say, consider you are working for Amazon, Flipkart, where they are selling products online. Okay, so the company has operational systems. The company has operational system. What is operational system? So you have a web application. So you have a web application. So you have users. They are accessing your web application. So users can be from web. They can be from web or mobile or are different like users, right? Different users are accessing your web application. So you have front end application and you have backend. Backend, and this backend is on the cloud, and you have a database. You have a database. Okay, so this is how, let us say Flipkart or Amazon, right? So their web application architecture is. So you have front end, back end, and database. So your data is are permanently stored here. So data are permanently stored in database. Front end, web page where users are accessing and they are buying product, selling product. So here is where users are interacting with the web pages here. And front end communicates with your backend, and backend stores the data permanently in database. So here we use OLTP, OLTP system. Okay, so it can be MySQL, SQL Server, Oracle, it can be different kind of RDBMS system. Okay, why RDBMS system here? Because these data are coming very frequently. It's a fast access data. Data are coming very frequently. You are storing, you are doing row level operation. You are doing row level operation. So this data, so one user is updating his user information. One user is like changing his order detail. One user is buying a product, selling a product. They are ordering something. So everything are row level transaction. So you are doing row level transaction. And here, this is an operational system. This is an operational system. So in an organization, there can be multiple operation system. There can be like 100 plus operation systems. So like this web application, they may have 100 plus web applications. Okay, so all the data will be stored in database. This become one of the source for us. Okay, so for analytics, for doing business intelligence, for building dashboard. So I let us say for Amazon or Flipkart, I want to see how much is the sales of my product. My customers are buying the product. So my customers are buying the product online. I want to see sales of last week, or I want to see sales of last month, or I want to compare with the last year. I want to see the last year. So I have to take this data, store it in a centralized place, then only I can do analytics. Okay, if I want to build a dashboard, or if I want to build a report, for different scenarios. So for different business problems. So I have to store this data in centralized place. So you take the data from operational system, you bring it to your data warehouse. Okay, so this become one of the source for us. So your in your organization, who works on the system? Software engineers, full stack developers, front end engineers, back end engineers, they work on the system. So they work on the system. But for us, this database is one of the source. Okay, this is one of the source for us. So we don't have to understand in depth about this architecture, about the web application, what it is doing, how the data is getting stored. We don't have to get deeper into the system. We are going to use only this database, not about the entire system here. Okay, so this operational system is one of the source. You can go to our system. You can see here OLTP database. You can see OLTP database. So for our Snowflake data warehouse architecture, your OLTP operational system is one of the source. Like that, we have various sources: enterprise applications, legacy application, third-party application, logs, web logs, IoT data, like different data are coming in, all are become sources for us. So you are going to collect this data and store it into raw layer. So in Snowflake, you are going to create multiple layers. So within the Snowflake itself, I'm going to create multiple database, I'm going to create multiple schema. So I can store the data in raw form. Okay, so I can store the data in raw form, then I can transform it later. Okay, in Snowflake, you can store the data in raw form or transform form. So you have multiple options. So in Snowflake is a platform. When you have a platform, they provide you multiple options. Okay, so it's not like a database, right? You can store only one form. It's not like that. It's a platform where you can do multiple things here. So I can store the data in raw form also. I can transform and store it also. Okay. So this process of loading the data is called ingestion. So ingestion is nothing but collecting the data from source, loading into Snowflake. That is what ingestion is about. So we are not doing any transformation. We are just loading into Snowflake here. Okay, I see few questions. I'll answer all the questions. I'll answer one by one later. So we will discuss about why ingestion tools are not needed. I'll explain about that. I see a question on that. I'll explain about that. I'll explain about that later. Okay. So Snowflake is a cloud-based data platform. Okay, it's not a data warehouse. It's not only a data warehouse. Okay, so it's not only a data warehouse. It's a data platform. So you can use it for different purposes. So I can use it for different purposes. I can use it for data engineering. I can use it as a data warehouse. We have seen that core capability of Snowflake is a data warehouse. Other than that, you can use it for storing into data lake. I can use it for data science. I can use it for data sharing. So I can collect the data from sources. I can do different things in Snowflake. It's a data platform. You can do multiple things in Snowflake. So previously, let us say like your data warehouse, Snowflake is there for more than 10 years. Initial stages, they were using Snowflake only for data warehouse. They were using only for data warehouse. Companies were using Databricks for data science, for data engineering. They were using, they were doing using Databricks. But now if you see all the future which is there in Databricks has been you like brought into Snowflake also. So all the future which is there in Databricks is it's there in your Snowflake also. That is why it's a data platform. You can use Snowflake as a unified data platform. So you can use it for multiple purpose, not only for data warehousing capability. You can use it for data science. You can use it for data engineering. You can use it for different data related capabilities. That is why it's a data platform. Okay, so we are discussing about OLTP, OLAP. So what is transaction data? What is analytical data? We are discussing about that. So we need to understand data lake. So we need to understand data lake also. So let us see that. So in your organization, you are collecting the data from external system. You are collecting the data from operational data. You are bringing it in data warehouse. Okay, so here in data warehouse, you can store the structured data only. Okay, so the data you can store in structured form. So you can create a table. So in your Snowflake, you are going to create a table and store the data. Okay, so what about flat files? I have CSV file, I have JSON files. What about images, video files, different semi-structured or unstructured data? So when you're working on organization, when you're working on analytics or data science, so in data science, they capture images, they do machine learning models, they do predictions based on images. They capture videos, they take the videos and they predict based on the videos. Okay, so they need to store the unstructured data. So they are going to, when they are working on data science, they need unstructured data. So where you will store unstructured data? Data lake is a place where you can store structured data, semi-structured data, unstructured data. Okay, so that is why in enterprise they use data lake. So data warehouse, you can store only relational form of data. You can store the data in table form. So you need data to be in structured form. You need data to be in structured form, and we follow data quality. We maintain a table schema. So we maintain a schema for their data. So and we create governance. We give access to this data. So we say that only few people can access that, few should not access. So there is a data governance. There is a strict rules are followed for using the data. Okay, so when you are using data warehouse in organization, the permission, policies, governance are applied, and you can store only structured data. But when I'm going to work with data science, or when I'm going to work with AI use cases, generative AI or AI use case, I have to store different form of data. So they use data lake for that. So data lake, what is your data lake? It can be S3. For example, I'll go to AWS. You can see AWS. I have S3. So S3 is a data lake. In S3, I can create a bucket, store different form of data. So I can store different form of, it's nothing but like your local folders, right? So like your local folder in your machine, Windows machine, you store a lot of data. So this is on the cloud and it is very cheaper. You can store any type of data. I can store CSV, images, video files, audio files. I can store different type of data. I can just create folders and store. So in organization, for dumping lot of data, they store raw format of data, use it for data science, machine learning activity. They use data lake. Okay, so here there is no governance, integration is low, and you can store the data in raw format. Okay, so that is why we use data lake. So in organization, they use data warehouse also. They use data lake also. We will discuss about Lakehouse architecture. Later, we will discuss about Lakehouse architecture, which is the latest one. We will talk about that. It's a combined feature of data lake and data warehouse. So in organization, they use database for storing operational data. It's a structured data. So it's a structured data and it has a schema. You are creating a table and storing it. Okay, this can be your MySQL, Oracle, SQL server. And they have data warehouse for storing organization-wide data. So organization-wide data, again, it's a structured data. They are going to create a table and store the data. So it can be your Snowflake, Redshift, BigQuery. So your data warehouse. Data mart are nothing but department specific data. Okay, so it's a simplified version of your data warehouse. Data marts are nothing but your data warehouse, but it has only organization department specific data. Like sales team, you have a sales team, they are using a Snowflake and they have only sales team data. So that is called as data mart. Okay, so within your organization, they can have multiple data marts. Each business group can have their data marts, and organization wide data can be in data warehouse. So sales team stores uses a data warehouse, and that is they have only their own data. It's called data mart. Okay, so within the organization, they have different kind of data marts. So they have department specific data, and data lake are used for storing structured, semi-structured, unstructured of data. Okay, so it's used for big data analytics, machine learning, different kind of use cases. Yeah, you can say a data mart is a subset of data warehouse. You can say that it's nothing but a data warehouse, but it is specific to department. It's specific to different specific business purpose. You are storing the data for specific business purpose. That is what a data mart is about. So when you are working on data mesh architecture, I have explained that about data mesh architecture. So let me see if I can. Okay, you can see here. So when you are working on data mesh architecture, which is a decentralized operation. So when you are working on data mesh, decentralized, that means I don't want to store all the data in centralized place. Instead of that, I want my department to refine the data. They want to refine the data and bring the data into my data, data architecture, into my data mesh. That means each department has their own data marts. From the data marts, data are coming into data warehouse. Okay, so each department has their own data marts, and they are storing it separately, and they are bringing into data data warehouse. So all this thing can be a data marts, and you have a data warehouse. Okay, so each department can have their own data warehouse, which is called as data marts. Okay, so far we have discussed about what is data warehouse, core purpose of data warehouse, and we are going through what is Snowflake. So far we are going through what is Snowflake. So we understood that in organization they use database, they use data warehouse, data marts, and data lake. Okay, so they use different kind of storage system. All these things are storage system where they are storing the data. Okay, so the purpose here is, so this all the systems are used for storing the data. So here in database, you store data permanently, data warehouse, you store permanently, data mart, you store all these data are stored permanently. So they are used for different purposes. They are used for different purposes. Data science, analytics, dashboard, reporting. So enterprise has different kind of products. So for various product, the systems are used. Okay. So Snowflake is a cloud-based data platform where you can use it for data warehouse, analytics, and data collaborations. Snowflake, you can run it on AWS, Azure, or GCP. Okay, it runs on different cloud. So initially they started with AWS. Then they started supporting Azure. Then they started GCP also. Okay, so they have a lot of integration initially supported for AWS. Okay, so AWS and Snowflake work together very good. So a lot of features are supported easily. And with Snowflake, it's a SaaS product. Okay, it's a software as a service. So you don't have to create a server. You don't have to manage it. You don't have to manage the infrastructure. You are going to access the product and use the product. Okay, so they provide it as a service. They provide software as a service. So it's running on top of cloud. Your Snowflake is going to run on top of cloud. So that is why it's a cloud native data warehouse system. Okay, it's a cloud native data product, data platform. So in Snowflake, you are going to do a lot of SQL. You can use SQL. You can use Python also. You can use web UI. You can use JDBC connection. You can access it by APIs. Okay, so different ways you can access it. Okay, so in Snowflake, in the Snowflake, let me go into Snowflake. Okay, so here you can see this is the web view console of Snowflake. This is a web console of Snowflake. I can log in using username and password, and I can access Snowflake. So how I'm doing it, I'm not doing any installation. Snowflake is providing a free trial. So they are providing a free trial. So where anyone, because it's a SaaS product, anyone can use their email ID, sign up to this. So for a student trial version, they are giving 120 days free trial. Okay, they're going to give you 120 days free trial. So you can use your email ID. It can be Gmail, it can be in your personal email. So they are saying work email, but they support Gmail also. Okay, so they support Gmail, and you can sign up. And here, once you sign up, so once you sign up with your details, they will ask for you to select the cloud provider. Okay, so the first step is this one. So for example, you can see the first step is this. So if you are not using student, if you are going for signing up for normal Snowflake, it's a 30 days one. So the 30 days free trial. But if you're going for student one, so you don't have to provide any identity. You can just use this URL and sign up for student account. You get 120 days free trial. So for the entire course, you can use this free trial version. And once you give your email and when you sign up, they are going to ask you to choose the cloud provider. Okay, so they will ask you to choose Azure, AWS, or GCP, and what region. So they are going to ask you to choose this. So you can choose US region here instead of Asia. You can choose US region, and AWS you can choose. You can choose AWS here. Okay, so that when you choose US region, they provide you latest future. So with the US region, like Cortex analyst works on US region. In Asia, still it is not supported. So all the latest future are supported in US region. And you can select enterprise here. Instead of standard, they provide different version, standard, enterprise, business critical. You can go for enterprise here. So which is used in the organizations, which is used in the enterprise. So you can go for enterprise and you can select cloud provider as AWS, and you can select region. So once you do that, you will get an email. Within using that email, so you'll get an email, and using that email, they will get a URL here. So you'll get a URL. So using that URL, using the username and password, you can log into Snowflake. Okay, that is how you can access your Snowflake. So Snowflake is a cloud-based data warehouse system. So you can access it on the cloud. So if you have web browser, if you have internet connection, you can use Snowflake. So you don't need any server, you don't need anything. You can just access the URL, access username and password, and access it. You need only internet connection, you can use Snowflake. So Snowflake is built on top of cloud. So Snowflake server is built on top of cloud. So they are integrated with your cloud provider. Either it can be AWS or Azure or GCP. And in Snowflake, you can write SQL or Python. You can write both. And we are going to access Snowflake from web UI or using JDBC connection, or you're going to connect with APIs. So different ways you can access Snowflake. So these are the different ways you can access Snowflake. So we are going to use everything, right? So we are going to access using web UI, web interface. So this is, we call it as web interface. So let me go into web interface. So this UI is called web interface. Snow site, it has different names, web UI, snow site, or web interface. So using the username and password, you can log in. So I already have registered and I have done all the steps. So as I said here, I have done all the steps. I have logged in, given an email ID, I get signed up. I got an email, then I have activated it. Then I got a username and I reset my password. So I've done all this thing. So let me log into Snowflake. Okay, so so for Snowflake, you don't need to do any installation. You are going to access it from web UI. Okay, so you need an internet connection and you are going to access it from web. So I can create database. So I can create database. I can store my data. I can store my data. I can store the data in structured form. So I can store the data as a table form here. So let us go to some. So I can create a database and store different type of data. So I can store data here. So I can see the count, number of records. I can see the data. I can preview the data. So I can see the column. I can see the table type, the table details. So from Snowflake Web UI, after signing up, I can start accessing my database tables. So we can start using different things in Snowflake. So you can store the data and you can start using it. Okay. So I'll share the link. I see a lot of questions coming in. We will discuss about the questions one by one. I'll tell you about all the questions. Let me share the link first. Okay. So you can create your trial version. Okay, you can create your trial version. You can sign up with the Gmail and then create your. So you can select, as I said, you can select AWS or Azure. You have options. You can select AWS or Azure. Select US region. Okay. So if you see my account, I am using AWS. I have chosen AWS and I am on US West. You can see US West. So as I am using US West, I have option to use Cortex Analyst. I can use like latest future. So I can work on the latest future which is available in Snowflake. So they support first US region. All the latest future will be supported in US region. Then they slowly give permission to other regions. Okay, that is why by creating your Snowflake, you can go for US West or US East, US regions initially. You can see here multiple accounts, multiple regions. You can see multiple accounts and multiple regions. So here in Snowflake, I can go and see initially when you log into your trial account, you will be given admin privilege. So you are logged in as an admin. So you see all the options. You will see all the options. Like you can create users, you can see your cloud cost. So as you are logging as an administrator, you have lot of privileges here. Okay, you can see your compute. So you have a lot of options here. But when you are going to work on organization, you cannot see all this thing. You will have limited permission. You are not going to see all this kind of options. But with a trial account, you are going to see a lot of options. You will see all the like governance, compute, administration. You will see all your account details, everything you can see. Okay, so that is what trial account you are logging as an administrator here. Okay, so far we discussed about what is Snowflake, and I showed you how you can access Snowflake, how you can access Snowflake, a trial version of Snowflake. Okay, now we will see in Snowflake how data are coming. So we saw that we are storing data into Snowflake. So in Snowflake, I create database. I am going to store my data. Okay, so the data are going to come from different source system. So Snowflake is meant for collecting the data from different system and storing it here. Okay, it's a storage system where you're going to store it. So you need to know what are the various ways I can bring my data. For that, you need to understand what is ETL, what is ELT. Okay, so what is ETL, what is ELT, you need to understand. And here you need to know what is batch processing, streaming. Okay, so let us discuss about that and then we will get into the next one. So you can go for, I see a question, Snowflake edition we should choose. You can go for enterprise edition. So when you are choosing edition, so you can go for enterprise edition. Don't choose standard. standard will have only basic feature. You can go for enterprise, which has a lot of the enterprise use cases. So you can choose the enterprise edition. Okay, so let us see first what is ELT, and then we will discuss about next thing. So here, let us discuss about ETL and ELT. Okay, before this, so as I said earlier, we have OLTP, OLAP. Okay, so we have OLTP and OLAP. So we have OLTP and OLAP system. So OLTP, who is using it in organization? Who are the users bringing the data? So it's used by operational system. It's used by operational teams. That means there are multiple web applications, enterprise applications. They are storing their transactional data. So they are storing their transactional data. So your OLTP system are used for storing transactional data. Okay, so here you are doing row level operation. You are going to do row level operation. The problem with your OLTP system is it's not scalable. That is the biggest problem. So it cannot store large amount of data. So I am working for a smaller organization. I have only 10 users or 100 users. Do I need to worry about scalability? I don't have to worry because I have only 10 users, 100 users. My transaction will be less. But when I'm going to work on a bigger organization, they have a bigger use base. They have user around the globe, and they have 1 million or 100,000 users, and there are a lot of transaction happening. Okay, and they are doing a lot of things. They are not only like, for example, if you take Amazon, right? Let me go into Amazon or Flipkart. So I'm going to talk about a lot of scenarios, some specific e-commerce scenario. It's easier for everyone to understand. Okay, so e-commerce scenario, I'll take it always e-commerce scenario because it's easier for everyone to understand. But I'll cover a little bit on banking or insurance, little bit on for security compliance. I'll talk about banking, insurance, and I'll talk about supply chain for enterprise use cases. When you're working on industry, when you're working on manufacturing use cases, we will talk about supply chain. The project we are doing on logistics. So we are going to cover multiple domains. Okay, so we are going to cover about multiple domains. It's not only about e-commerce. So I'm going for Amazon. Let me go for Amazon website. So you can see in Amazon website, when I search, when I'm going to buy a product, it recommends me a lot of things. So it recommends me based on my previous searches. It recommends me and shows latest product, where these data are coming from, So the data is stored in a OLTP system. So all these products are stored in OLTP, and the quantity, the customer details, the seller details, everything are stored in OLTP database. What about the recommendation? What about the suggestions? What about the different, like I'm doing a lot of activity. I'm browsing this page. I'm adding some item to catalog. So I'm doing it today. Like daily, I'm going to do a lot of things. So this activity, user preferences are also needed when you're going to do intelligence, when you're going to do data science, or when you're going to do work on generative AI use cases. You need to have transaction data also. You need to have other data also, like users activity, users logs, user preferences, different user information. Then only you can work on different use cases here. So you cannot store all your data into OLTP. Okay, so if I store all my data into OLTP, like I have, let us say, I have MySQL in my organization or SQL server. Let us take SQL server. If I'm going to store all the data along with my products, along with my user data, so you can see here, my product informations are here, my previous orders are here, my previous purchases are here, my user information is here, my user information is here, and product information is here. My activities are logged. So if everything you are going to store it in OLTP, this will go down. This will crash. It will have performance issue. And OLTP is like, the problem is scalability. It cannot scale horizontally. It can scale only vertically. What is vertical? You can increase the power of the machine. So that means you can increase CPU, you can increase RAM. Okay, so you can have one powerful machine, but it is going to be costly. It's going to be costly for having high CPU, high RAM. It's going to be costly. And when you are going to store large amount of data, it is going to do row level processing. It's going to do row level processing. So the row level processing, it's slower when you store large amount of data. Okay. So when I'm going to do some analytical operations, so when I'm going to do analytical operations like group by, when I'm going to do some aggregations, this row level operation will perform poorly. Your performance are going to be poorly. So this is not suitable for analytical operations. So your MySQL, Postgres, Oracle, SQL Server is not suitable for analytical problems. To solve analytical problem, you cannot use OLTP. You have to go for OLAP system. The OLAP system are designed for analytical purpose. It's like online analytical processing system. So where their main purpose store large amount of data and it is horizontally scalable. It's horizontally scalable. That means you can add more machines. If your data is huge, you can add more machines and your data is column, it's stored in column level form. Okay, so data is stored in column level form. I'll explain about that. We will discuss about column level storage later. We will not get deeper into it now. Later we will discuss about it. As I'm storing in column level form, I can do aggregation operation easily. Okay, so I can run batch queries. I can do bulk operation easily. Okay, so the problem with OLTP system, you cannot do bulk operations. Okay, so you cannot use for analytical purpose. As OLAP system, as it is horizontal scalable, so it can add more machines and you can store the data in column level form. So it can be used for different analytical operations like BA operations, business intelligence operations, data science operation, predictions. So you can use for different kind of operations. Okay. So in organization, they have OLTP also. It's not that organization doesn't have OLTP, right? They have OLTP, which is used by web application, which is used by enterprise application to store transactional data. And it has 6 months of data, 1 year of data. Historical data will not be here. So only recent data will be. And historical data will be stored in OLAP system. Okay. So in OLAP, you are going to collect the data from your OLTP and store it here in regular form. You're going to store the data in regular form. So in OLAP system, so you do ETL, you do ELT. Okay, so you work on batch processing, streaming. So REST API. REST API. So what is REST API? So as I said before, when you are working on OLTP system, so when you work on OLTP system, front end to back end, this call is called REST API. Okay, REST API, where it goes request. It is a web request and response. So your REST API or on-demand system. It's an on-demand system. On-demand means when request comes in, response is. So request can be like 10 records, 100 records. So here it can be 100 records. Response can be for 100 records. Here I am not going to like send 1 million record. I'm not going to get 1 million response. Okay, if you are going to do that, this will get timed out. So in REST API, you cannot use it for bulk operations. So this you are going to do row level processing and it's for smaller transaction. It's meant for smaller transaction. Here you cannot do bulk operations. Okay, here you can do 100 records or 1000 records. You cannot use it for larger volume of data. Okay, it's application API is nothing but application programming interface. So it's not when you in the organization, there are like software engineers, backend engineers, they work on REST APIs. The REST APIs can be built on Java, .NET, Python. So where you from front end, you are communicating with the backend and you are talking with your database or talking with server side using this programming language. It's a programming language which is written on Java, Python. So your software engineers, they work on this where it's a row level operation and it's meant for smaller transactions. Here you cannot do large volume of data. So this REST API, if I use for large volume of data, it will get timed out. So it has a time limit. If it is above 1 minute, if the request is above 1 minute, if the processing takes above 1 minute, it will get timed out. Okay. So REST API, we cannot use it for, it can be used only for operational system. It can be used, it is most frequently used for operational databases, used for operational systems. Okay, so REST API is for on-demand for smaller data set. What about bulk data set? So as I discussed earlier, I have different source system. Let us take enterprise application. So I have SAP. From SAP is for used for like enterprise resource planning. SAP is used for enterprise resource planning. So I have an industry. I have my lot of like industries. In industry, they have a planning system where raw materials comes in, and the operational teams works on the manufacturing the products. So everything is planned on SAP. SAP is a ERP system, and planning is done. You don't have to learn about all the system. So you don't have to go and learn about all the source system, right? Because in enterprise there are 200 plus or 300 plus source system. If you are going to learn all the source system, if you are going to learn what is enterprise, what is web application, what is like OLTP system does, it is going to take a lot of time for you, and you cannot learn it also. So you will not know all the systems. So you need to understand how the data is coming from that system. That is enough. So these are all are called upstream systems. So they are sending data to us. We are going to take the data and use it. So we don't need to understand the what internally the system is doing, what data the system is sending. That is what we have to understand. So here, let us take SAP. The SAP is a planning system. There, some business users are doing some planning, and they are sending data. That data they are sending me in CSV file. So let us, it's a flat file. So for example, let me show some data here. So they are sending me in a comma separated file or JSON file or JSON like a tab delimited file. So I'm getting the data in different forms. I'm getting data different forms. Like let me go into bigger data. So like let us say this is one data. So I'm getting some sales data from SAP. So it's like if you see the data, it looks like this. Comma separated data. It's a comma separated. It has a header. It has a header. So the first column is a header. Okay, this is a CSV data. So this data is large in size. So data is huge in size. So this data, I have to process it. I have to store it and process it. So I have to take this data and load it into my database. So I have to do a bulk operation. This is called bulk operation. So this thing, you do it with batch processing. So using batch processing, you process the data in bulk. Okay, so you process the data in bulk. So with the batch processing, the frequency here, it can be weekly activity. So weekly I'm accessing SAP, getting bulk data and loading it. It can be daily, it can be hour. Okay, so this can be scheduled and you can run it weekly, daily or hour. So within using batch processing, you are doing bulk loading of data, bulk migration of data or bulk loading of data. So you are doing bulk processing of data using batch processing. So you take it from sources, load it into Snowflake. You can do it weekly, daily or hourly using batch processing. So what about streaming? Here, I have a system which is sending data lively, like IoT systems. IoT are devices which are sending data lively for every 5 minutes, okay, or every 1 minute. So here, it's streaming of data. It's streaming of data which is coming live. So my pipeline here, it's a 5 minutes pipeline or 1 minute or 2 minutes pipeline. So here you can, it's a continuous pipeline. This is a continuous pipeline where data are going to come continuously. You are going to process the data continuously. So this use cases are there in logistics. It's there in retail, banking. So streaming use cases are there. So we may work on batch processing, streaming, or REST APIs. So REST API is not frequent. REST API, you don't need to get deeper into REST API, but batch processing is our core area and streaming is another area. Streaming. So the first project we are going to work is on batch processing. Second project is on streaming. Okay, so we are going to do two projects. First project on batch processing and second project on stream. So this is how, like in the system, you work on batch processing or REST API. In your organization, you may work on all this thing. So like when you join an organization, they may put you on any of this. Okay, they may put you on batch processing, streaming, or REST API. They may put you on any of this area. So you will not get chance to work on all this thing. So you don't have to master all this thing, but you need to focus on one thing. You need to focus on one thing like batch processing or streaming or REST API. Okay, so here we are going to start with batch processing, and then we will see little bit on REST API, and then streaming will cover. Okay, we are going to cover all this thing, but we are going to focus more on batch process. That means how data processing bulk, weekly, daily, hourly. So this processing can be in full load or incremental load. So we are going to cover all this scenario. Okay. So what is ETL? So we have seen so far batch processing. So that is taking a data and loading it. So what is ETL? So ETL is about extraction, transformation, and load. Okay, so ETL is about extracting data, transforming and loading, or extracting data, loading and transforming. Okay, so you can see here ETL, ELT. So what is the difference here? So ETL, what you do, you extract the data, transform using different tools. For transformation, use different tools and load it. ELT, what is the purpose of it? You take the data, bring it into raw form, bring it in the raw form, then transform it later. Okay, then transform it later, or load the data into data warehouse, transform it later. So you're going to transform it later. You are storing the data in raw form. Okay, in enterprise, they use both. Okay, few scenarios they use ETL, few scenarios they use ELT. So we need to know both. Okay, we need to know both. How to store the raw data, how to store transform data. We need to know both. We will learn both in the courses. Okay, so we are going to learn both in the courses. So from source systems, my source system, I'm going to take the data, do the transformation using different tools. Here I may use different tools like Glue, like ADF. I can do transformation on different tools. I can use Databricks, then load it into Databricks. So I'm not doing transformation in my data warehouse. In the ETL scenario, I'm using data warehouse only for storage. I'm storing only the transform data, aggregated data, I'm storing into data warehouse. Okay, in the second scenario, in ELT, I load the data into raw form of data into data lake or data warehouse. I store it into raw form of data, then I transform it. So you use different tools for transformation and do it. Okay, so we cannot say a most common one, right? Which is preferred or most common one. Both are used. So in enterprise, both are used. So why both are used? So I'm working with the data science team. They need raw form of data. They need aggregated data. Okay, so I have a data science team. They are working on machine learning models. For machine learning models are nothing but a Python-driven algorithm, Python-based algorithm. For that algorithm, to fine tune it, to make the accuracy better, they need lot of parameters. They need lot of data. Then the accuracy will be high. So they need raw data also. They need aggregated data also for data science team. I have a BA team which is there in a different group. They need aggregated data. Okay, so for BA team, they want only aggregated data. For data science team, they need raw data and aggregated data. So I will store in my data warehouse. So in my data warehouse, I will create bronze catalog and I will store raw format of data. I can store raw format of data and I will create silver catalog. I'll create a silver database and I'll store my process data. Okay, so I'll store process data and I'll have aggregated data in different layers. So I'm going to have 3 layers, multiple layers like bronze, silver, gold, and have different form of data. So I'll give access for my BA team. I'll give access only to gold. Okay, the aggregated data I'll give access. For my data science team, I can give access to silver. I can give access to bronze. I can give access to gold. Based on the need, I'm going to give access to different things. So here I'm doing ELT here. But I'm extracting, loading the data into bronze. Then I'm doing transformation. So I'm doing transformation. I'm doing ELT here. Okay, so in your organization, we use both based on the project, based on the consumers. We will do ELT or ETL. Okay. Okay. So far we have seen about why ETL. What is the purpose of ETL? Why ELT? So what is ETL and ELT? Okay. Next is why cloud? What is the purpose of learning cloud here? So even though we are learning Snowflake, why we need to learn AWS or Azure here? Okay. We need, so what is cloud first? We need to understand what is cloud. That makes easier to understand a lot of things here. Okay, so we'll understand what is cloud. So cloud providers like AWS, Azure, right? So what they are providing? They provide resources. So you want to store some lot of data, or I want VMs, I want virtual machines. So for my organization, they have on premises. They have on premises. That means they have data center. So they have data center. So in data center, they have physical servers. I can install my application there and use it. But they need an administrator, they need infrastructure team to manage it. So 10 years back or 15 years back, companies were maintaining data centers and they were having physical servers. They had an infrastructure team. Now, lot of company like startups, even big companies are more into cloud. With cloud, they provide you service. They provide you service. So they provide you if you want machines. For example, you want Linux machine. I'll go to AWS. So if I have web browser, I can go into AWS console. So this AWS console, you can log in. So let me open AWS console. So you can create an account. You can create a free trial account, and then you can create in the organization. They will already have an account. They will add you as a user. So they will add you as a user for AWS or Azure. So in the AWS console, this we call it as AWS console, you can access different service. You can see all services. You have different service based on the purpose you need. So I want to create Linux machine. I want Linux machine. I want for 1 month. So I can go to EC2. So in EC2, I can launch server. They are providing you server as a virtual machine. So I can choose different type of instance. So based on my need, I can go for powerful machines. So I can choose 4 GB machine, 4 GB RAM, 1 CPU, 4 CPU, 8 CPU. I can choose different powerful machines. I can choose different type of machine. I can select OS, different OS, Mac OS, Ubuntu. I can select Windows, different OS, create machines here. I can create one machine or 10 machines. Okay, so using AWS, they have a EC2 service. Using EC2 service, I can create machines, virtual machines quickly. Okay, so I can create it, use it for 1 minute, 1 month, and pay for only 1 month, then stop it. Okay, so it saves companies cost. They don't need to provide like maintain an infrastructure team. They don't need an admin. They don't need to maintain a data center. They don't need a physical server. So everything is saved. They're going to pay 1 month of fee. So here they're going to pay 1 month of fee. So that is how cloud provider they provide different services. They provide different services for compute, for storage, for database. They provide database as service. They provide virtual machine as service. They provide different analytical service. So there are 200 plus services here. There are 200 plus services for different purpose, for machine learning, for IoT, for game development. So they provide different services. So you can use this service and pay it monthly. So this helps organization. So they don't have to maintain infrastructure team. They don't have to maintain any infrastructure team. They can build their software. They can work on their core competency. So if the company is on retail, they can work on their application. They don't have to worry about infrastructure. So the cloud provider, they provide you resources. So the cloud provider, they provide resources. That resources can be storage. That resources can be VMs. That resources can be compute, containers, network, security. So they provide all these services. And also they provide you storage. The storage can be data lake. So you can see here storage, data lake. So data lake has become very popular. Okay, why? Because it's cheaper. So for 1 TB of data, if I'm going to store 1 TB of data, for monthly I'll pay only $10 or $15. Okay, that is how your data lake is cheaper. Data lake is cheaper. So it's like a drive. It's a drive, right? So you are using Google Drive for storing data. It's like a drive for enterprise purpose, organization wide data. They can create different buckets and store the data. So I can store my historical data, I can store my analytical data, I can store my video files, audio files in bucket. So I can create a cloud account for the storage. I can create a new cloud account for different purposes. For different purposes, I can store all the data into data lake. Okay, so that is why we are dependent on cloud. So your data warehouse system, your Snowflake, is built top of cloud. Okay, so your data warehouse system is built top of cloud. They use the storage, they use the network, they use lot of things from your cloud provider. Okay, so if you are storing data in Snowflake, underlying Snowflake stores the data in data lake. Okay, the Snowflake stores the data in data lake. We will discuss about that later. How Snowflake architecture, how data is stored. We'll discuss about that in next week. For now, you can understand that your Snowflake is a cloud native system. Without cloud, your Snowflake will not work. Your Snowflake cannot be used in on-premises. You cannot install Snowflake on on-premises. It works only on top of cloud. Okay, and stores data only in the cloud. So you need a cloud account. With a cloud account only, you can access Snowflake. Okay. So we have seen you can use AWS, you can use Azure. Okay, so you can create AWS. So AWS, Azure are competitors. So whatever we do it in AWS, I can do it in Azure also. So Azure also provide the same kind of services. So if you go to Azure, so with your Gmail account, with your email ID, you can create your account, start using AWS or Azure. Okay, so here you can see all services. Like AWS, you have different kind of services like compute, storage. So we call it as for data lake, for storing large amount of data, we call it as S3 there. Simple storage service. So in AWS, we call it a simple storage service. In Azure, we call it as data lake storage. ADLS, we call it as Azure Data Lake Storage. Okay. So here we call it as ADLS Gen 2, Generation 1, Generation 2. So here again, you can use all the services and pay monthly. Okay. The advantage here is cloud providers are helping organization in creating provisioning resources and helping you to store your data or create your network, create your missions. So that is where your cloud providers are going to help you. And when you are going to work on your cloud data warehouse, you are going to work with your providers. Your data will be there in S3. So I have to access my data is there in S3. I'm going to use the data from S3 or my data is there in Azure. I'm going to access the data from Azure and use it. So you are going to access data lake, get the data from data lake and use it for your use cases. So you should either create AWS account or you should create Azure account, because when you are going to work on Azure integrations or AWS integrations, any of this is enough. Okay. So like let us say I have sources, data sources. So I'll say my source, the OLTP. My source is OLTP. So for our use case, we are going to use MySQL or SQL Server. Okay, this will become a source. So this source data, we are going to load it directly into data warehouse. Okay, we are going to load it into data warehouse. So this is Snowflake. So when you are going using data warehouse, you have a staging layer. You have a staging layer. So this staging layer is a temporary area where you bring the data here and then copy into warehouse. Okay, so Without staging layer, you cannot copy the data into Snowflake. Okay, so you create a staging layer, you bring the data into staging layer, then you copy to Snowflake. So this makes your copy loading data faster. So you use staging layer, make your performance faster. Okay, so if I'm directly loading from here to Snowflake, my performance will be slowed. Okay, by bringing it to staging layer, loading the data into staging layer, and loading the using copy command. You call it as a copy command. We'll discuss about that all the commands later. So by loading using the power of staging layer, your performance is going to be faster. So you are going to load the data into Snowflake using staging layer. Okay, so staging layer. So this staging layer is nothing but it can be your AWS or Azure. Okay, it's going to be AWS or Azure. It can be S3 or it can be ADLS. Okay, so from the system, or I'm saying about OLTP. So let me talk about ERP also. So let us say ERP. So from ERP, I'm taking CSV. I'm having Salesforce. From Salesforce, I'm taking JSON. So I have to load it into data warehouse. So this is my organization wide data warehouse. This is where my organization wise data is there. So to bring the data here, I have to come through staging layer. Okay, so I have to come through staging layer. I cannot load directly here. So I have to take this data, bring it into staging layer, then only we can load it. Okay, so you need an AWS account, you need Azure account, any of this. You don't need both. You can go for AWS. If you are someone new to cloud, you can use AWS because the AWS will be easier. Integration with Snowflake is easier. So you can start using AWS, create your AWS account. I'll share the URL. You can create your AWS account. I will tell about pricing, how you pricing is done. So you're going to create free trial account. So in AWS, we have a free trial account. So where they provide 6 months of free service. Okay, they provide you 6 months of free. So new customers get $200 credits. You have a free plan where you get lot of services as free. You get S3, you get a lot of other service. We are not going to use all this thing. We are not going to all use all. We are going to use only S3. So S3 is free. So you will not be charged. So they will ask for creating AWS. They may ask you your credit card details. You are not, they will charge you $1 only for validation. Okay, so when you are creating AWS account, they will ask you for credit card details. They will charge you $1. It's only for validation, and then they will charge you monthly. Your payment is done monthly. You are going to do manually. So if I have to pay here in AWS, they will not take directly from your credit card. You have to do the payment manually. Okay, so in AWS, in Cost Explorer, I'll show that how we do payment. Okay, so you are going to create a new account. I'll share this URL. You can see here bills. Okay, so AWS, when you create account, even though they are going to take your credit card details, but they are not take directly from your accounts. Will have to do the payments manually. Okay, you will have to do the payment manually. So you don't have to worry about the payment charges here. So you are going to use free trial. You are going to use free trial, and we are going to use only S3, which is part of free trial. So you're going to get 6 months free. Okay, so I've shared the link for AWS. Okay. So the AWS is required or Azure is required for storage integration. Okay, for the staging layer, for the storage integration, we need the AWS account or Azure account. Okay, so without staging layer, we cannot load the data into data warehouse. So we need to know some basics about cloud here, basics about using data lake. So some in AWS, we will learn some basic service. Like I will learn about IM and S3. We are going to learn two service, IM and S3, which is enough for us. Okay, so we don't have to get into other service. We will need to know what is IM, how to use IM, and what is S3, how to use S3. So two services alone is enough for us. That we will use it as a staging layer. And data coming from sources will come into staging, and then we will use it in the data warehouse. That is what we are going to do. So for ingestion process, we are going to use staging layer, and we are going to bring the data into data warehouse. So for that, we need AWS account. Okay, so far we have seen about what is the purpose of data warehouse and what is Snowflake. Snowflake is a cloud-based data warehouse, and what is ETL, ELT, and we discussed about why cloud, what is cloud. So why we are dependent on cloud here. So we need a cloud account to work on Snowflake. You need to have basic knowledge about cloud, especially on the data link. So in the enterprise, we are going to frequently use both. Okay, so we are going to use data warehouse and data lake frequently and data platform. So as a data engineer, we are going to work on data platform. Okay, we are going to work on data platform. In a data platform, so data, what is data platform? So in my organization, so let us say I am working for an organization. They have only one BA dashboard. They have only one BA dashboard. So for that, you don't need a data platform. Oh, you don't need a data platform. You can have one data engineer or one data analyst who is working on requirements, collecting the data, converting into business reports, showing dashboard or reports. Okay, so they don't need it. But when you are working for a bigger enterprise, bigger organization, they have different data problems. They have different data products. They have different data team. Okay, so you cannot keep everything as silos. You cannot have everything working in a individual way. Okay, you have to bring a centralized layer. You need to have a centralized team because data is reused for multiple purpose. So you have a centralized data platform where they are storing the data, and that data can be used for multiple purpose. So you combine different pipeline into one pipeline, one data pipeline. So that pipeline can be used by multiple teams. So that is where data platform. So data platform is built in organization, so that can be built on AWS cloud, that can be built on Azure. Your data platform can be built on Azure platform, or it can be in AWS. So if they built it in AWS, they use different AWS tool. Okay, if they use different AWS tools, AWS services, AWS services. If they are building in Azure, they use different services. So do we need to learn all these services? Do we need to learn all these different tools? You don't need to learn all this thing. You need to learn some basic service. Okay, so you need to learn some basic service. So in interviews, they may ask lot of things. When you're applying for Snowflake interview, they may ask for a lot of requirements. You don't need to know all this thing. You need to know a few of the things. That is enough. They ask you mainly because if you have worked on one of their requirements, then it's easier for you to work on their individual use case. Okay, so they put lot of services mainly to see if you have used any of the services. Okay, so it's not that they have listed all the services, you need to know all the services. It's not like that. If you have few experience on working on few services, I will tell you what are the services are important, what are the tools are important. We will focus on that only, and we are not going to focus on a lot of things. Okay, so in AWS data platform, so if you're going to work on AWS data platform, you can see data sources, you have data ingestion, storage, serving, consumption. So if you see this architecture, right, I'm sharing architecture. So here, this architecture is a ETL architecture. So here they are doing extraction, transformation, and loading into Snowflake and used by consumer. So it's not a ELT, it's a ETL architecture. So here they do transformation using AWS services. They use Glue, EMR. So you can see ETL section here. So they do ingestion. They collect the data from sources. They do ingestion, bring it into data lake, do ETL in the AWS, then they do load it into Snowflake. In this scenario, they use Snowflake only for data consumption, data serving. Okay, so they do ETL using different tools. So this is again one scenario which can be in organization. So in organization, when you join an organization, they use ETL tool, they do transformation and transform data, they store it into Snowflake. Or there can be a scenario like where you work on a project where they bring the data. So let me show another project, another architecture. Okay, here you can see this architecture. They collect the data from sources, they bring it to Snowflake, and they do transformation within Snowflake. So here they collect the data, bring it to Snowflake, and then they do transformation. So it's a ELT framework. So it's a architecture is designed for ELT. That means they extract the data, bring it to Snowflake, they have it in raw form, then they do the transformation. So in organization, the architecture wise, you need to understand different architecture. So in the course, we are going to discuss about different architecture. We will discuss about ETL, we will discuss about ELT, both different AWS architecture, Azure architecture. So if you are from new to cloud, you concentrate on one architecture. You concentrate only AWS, even though I'm going to teach multiple things because here we have students from Azure also, we have students from AWS also. So we will be covering both scenarios. We'll be covering both on AWS, both on Azure. So if you are new, you go only for AWS. So whatever scenario I'm going to tell for AWS, you can listen to that and you can skip Azure integrations, Azure integration, or you can listen to that. If you are interested in learning both, then you can learn both. Or if you are someone who is experienced, you are 10 years of experience, you are into higher level, you need to learn both. Because for an experienced higher person, like 10 years and above, you are going to work on different cloud. You are going to use both Azure and AWS, and you are going to work on architecture side. When you are going to work on architecture side, you need to know both the cloud. So you may use both the cloud. So you need to know both. You need to know both Azure also, AWS also, and integration for both also. Okay. So if you are a beginner, you can focus on only one integration. Go for either AWS or Azure. So in AWS, I use different services. In Azure, we use different services. So in AWS, we use Glue for ETL. In Azure, we use ADF for ingestion. We are going to collect using ingestion using ADF. So we are going to see different tools for different services. Okay. So you don't have to worry. There are a lot of services here, a lot of tools here. We are going to focus on few tools and few services which are required, which are frequently used in organization. Again, which are in demand. We are going to focus on only few services, not all the services which are in demand, high demand, and which are very frequently used. That is what we are going to focus, and not all the services. Okay. So even though we have Snowflake, why we need to go for Glue? Why we need to go for Airbyte? Why we need to go for ADF? Okay, so the core capability of your Snowflake is on data warehousing side. Okay, on the data warehousing, on storing the data, doing data modeling, data sharing. It's a power of your Snowflake is on after storing the data. But ingestion, you can use different tools. For ingestion, you can use different tools. So you can use ETL tools like Glue, ADF, or Airbyte, Phytron, which are very good for ingestion. Okay, so let us see this. Like even though we are focusing more on Snowflake here, so this is again a question which is asked very frequently. We are very focused on Snowflake. Why then I have to learn different tools for ingestion? So ingestion is the process of bringing the data into Snowflake. So I have a Snowflake which is used as a data warehouse. through ingestion process, I bring the data from sources. So I have, like, in my organization, there are 100 plus sources. Okay, there are 100 plus sources. Snowflake supports ingestion. Using Snowflake also, I can do ingestion. Then why I need to go for tools like ADF, Airbyte, Phytron, Glue. Okay, why I need to go for these tools? I can use Snowflake. So if I go to Snowflake, you can see here ingestion. Okay, so ingestion. So this, you have a ingestion here itself in Snowflake. Then why I need to go for the other tools? Because in the ingestion provided by Snowflake supports only few sources, supports like a 10 plus sources or 5 sources. But in organization, there are 100 sources. Okay, you have multiple data sources. So you have SAP, you have Salesforce, you have Oracle, like multiple data sources. In organization, there are multiple data sources. So for all the like 100 plus data sources, so for all the data sources, natively Snowflake doesn't support. Okay, natively Snowflake doesn't support, but these tools are meant for data sources. This tool supports 100 plus. So Airbyte supports like 200 plus sources. Phytron supports 200 plus sources. ADF support 100 sources. Okay, so these tools are meant for ETL. Okay, these are ETL tools, are meant for ETL. So you can use these tools. In organization, as we have multiple sources, we are using these tools. Okay, so you don't have to learn all these tools, right? So here you are going to, if you are from AWS side, you are going to learn Glue, or if you are someone from Azure side, you are going to learn ADF. So for Azure, you are going to learn ADF. If you are from AWS, you are going to learn Glue. Or if I don't want to write Python code, if I don't want to learn all these cloud-based tools, I can go for Airbyte or Phytron. Okay, so the Airbyte or Phytron are completely, Airbyte is open source. This is open source. Phytron is an enterprise product. So you need an enterprise license. Both are UI based tool. This both are UI based tool. You can do ETL based on UI. So you can configure my source, configure my target, do ingestion from UI. Okay. So in the course, we are going to learn different tools for ingestion. So we will learn using Snowflake also. Ingestion using Snowflake also. We'll use these tools also. Okay, so this is what we are going to learn in the course. So in industry, in the organization, we do all this thing. So I worked on multiple projects. So we use all these techniques. So we have multiple sources, multiple data source. So we are using SAP, Salesforce. We are using different systems. So I need to do ingestion using these tools. I have data lake. Data are stored in AS3 or ADLS. So we are going to do data lake. We are going to use data lake. So the ingestion is the first process. Ingestion is the first process. Then we are going to do transformation. Then consumption. So we are going to look into consumption. Okay, so in transformation, we will transform the data using SQL. We will transform using DBT. Then we will use Snowspark. If you are from Python, you will use Snowspark. So transformation you can do in different ways. And consumption, you will create data models here. So you will be doing data modeling. You will create fact tables, dim tables. So we will learn all this thing: fact tables, dim tables, star schema, Snowflake schema. So my consumers, they have different business problem. To solve their business problem, we are designing a data model, and we are providing them different tables so they can access the data in faster way. So for OLAP systems, for analytical system, we create the data models and we define this data model, we structure this data model so they can solve different problems and their queries can be faster if you design this data model in a easier way. Okay, so if you design this data model in easier way, so they can access their data and solve their different business problem. So we are going to work on ingestion, we are going to work on transformation, we are going to work on consumption. So all this thing we are going to do, and we are going to see live use cases, live project we are going to do it in the course. Okay. So now we will stop it here. So you can ask your questions now. So you can ask all your questions now. So I see few questions already. So these tools are going to use staging layer. Without staging layer, these tools will not work. So all these tools are going to use staging layer and load the data into Snowflake. Because for Snowflake, data can be loaded faster only by going through staging layer. You cannot directly load it into Snowflake. Directly can load it by using connectors, by using JDBC connectors or using API. You can do it directly, but performance will be poor. I can use like a API, Snowflake API, or I can use JDBC connection for loading that data directly into Snowflake. Okay, so I can use this way without using staging. I can use load the data directly into Snowflake. So let me create staging here. Staging layer. So I can, without using staging layer, using API or JDBC connection, I can directly load it data into Snowflake. But here I cannot use it for bulk operation. I can use it only for smaller transaction. This mechanism, I can use it only for smaller transaction, not for bulk transaction, because the performance will be slower. When you use for bulk transaction, this performance will be slower, because here, if it is smaller transaction, you can write it directly to Snowflake. When you have large data, you will go through only staging layer. The bulk data, it will be goes through only staging layer. Okay, asset property. What is asset property and why it is required? So let me discuss about the asset property. That is again a good question. Okay, when we discussed about database, so we have OLTP. So we have OLAP. In OLAP, we have data warehouse. And we have data lake. Okay, so we are storing structured data here. Structured data. Structured data table, we will say table data. We are storing the data in table form. Here also we are storing data in table form. I can store the same data here also. Okay, so table data, you can store it in all these places. Here, it's not scalable. It's highly scalable and it is highly scalable. And it is cheaper. This is cheaper. This is cheaper. This is costly, little bit costly. This is not scalable. So this is not scalable. So you cannot store large volume of data here. So with my OLTP, with my traditional RDBM system, it's not scalable. Here it is highly scalable. It is cheaper, but this is consistent. Okay, it's 100% consistent because it has asset property. Okay, so asset property, which tells you the data stored are consistent. So when my multiple consumers, when multiple clients or users, when they read database, they will get same result. Because of the asset property, they are going to get same results. Okay, that is what consistency is about. So when I have 10 users, when I have 10 applications, when they read one table, so let us say the table name is sales data. It has like 10,000 record. It has 10,000 record. Same sales data here, so let us say 10 million. So I have 10 million. So this is a transactional data. It's last 1 month data. This is 1 month data. This is one year data or 10 years data. Same data here stored here. So let us say sales data 10K record is here, 10 million is here. So this data, if my 10 applications are reading, they will get same count. They will get same count. So it is consistent. It's having consistent. Whereas here, if they are going to read from data warehouse has asset property. It has consistency. The data are consistent. So they are going to get same count. They are going to get 10 million. Okay, so when consumers, when they read it from data warehouse, they are going to have consistency. But if they read it from data lake, here you don't have asset property. There is no asset property here, and data is not consistent here. That is the problem with your data lake. Not consistent. Why not consistent? Because here we are storing the data in file format. We are storing the data in file format. So when ETL jobs are running, it can become corrupted. So because it doesn't have history, it doesn't have versioning, your data become corrupted. Data can become corrupted. So here there is no asset property. It's not consistent. Whereas your data warehouse has consistency. It has asset property. So that is why for BI, for business intelligence, for reporting, for a lot of real-time SQL use cases, they use data warehouse, then using data. Okay. So for large analytical system, for dashboarding, they prefer data warehouse for consistency. For high consistency, for high like asset property, they go for data warehouse. Even though data lake is cheaper, it doesn't have asset property. That is the problem with your data lake. Okay, so we will discuss about this. And we have one more called Lakehouse. Okay, we will discuss about Lakehouse. Lakehouse is built on top of data lake. It has asset property. Okay, it has asset property. You can store it Lakehouse. So in Lakehouse, you can build top of iceberg. So we will see what is iceberg. You can build a Lakehouse on top of data lake. This this is something which is at present it's trending in organization, but even this has some problem. Okay, this has problem which is not as your data warehouse. So data warehouse is a powerful one compared to all the storage system. So your data warehouse is powerful one. So I have multiple consumers. They are operating across different region. They are using dashboard. I have multiple business running. I have multiple business managers who are using dashboard. So which is the best system to use? Your data warehouse system. Okay, so your data warehouse and Snowflake. So Snowflake is a number one data warehouse system at present in the market, and can be used for dashboard reporting because it is faster when compared with all the system. It is faster and it is consistent. So for consistency and far faster response, your Snowflake is used when compared with other systems. Even with compared with your BigQuery or your Redshift or your Synapse Analytics, Snowflake is faster, and which is faster, and it is like highly scalable and highly configurable. So that is why Snowflake is preferred in enterprise than other systems. Okay, so we will discuss about this, why it is faster, how it is faster. We will discuss about all this. We need to understand the architecture, internal mechanism. We will discuss about this and we will compare with other system in the later sessions. Okay, so another question here. What is staging here? What is staging layer? Okay. So as I said, we have database in Snowflake. So we have database in Snowflake. So you can see database in Snowflake. So here I can create a SQL file. I can create a SQL file. I can create tables. I can create stage. Okay, so in Snowflake, I can create tables here using the SQL here. I can create tables. I can create stage. So I can create different Snowflake objects. So we are going to create multiple objects. So I can create multiple tabs here. So Snowflake Web UI, you can create multiple tabs. So I'm going to create multiple tabs. I can see database here. So if I go to one database here, I can see objects here. So I can see different objects. So tables, stage, file format, streams, task, all these things are Snowflake objects. So there are multiple objects. So if I click on stage, I can see my stage, AWS. So I can access my staging layer I can see the files within my staging layer. So you are integrating your AWS. So if you see here, I'll go to S3, Snowflake dates. So you can see here, I have mounted here. I have mounted my data lake as a stage here. So my Snowflake June 2025 bucket in S3, I have a bucket. This bucket is mounted as a stage and I can access all the stage files. You can access all the stage files. So if I copy the data, Snowflake can easily do it. Okay, as we have created stage, copying the data from stage is easier. Loading and unloading data is easier. Okay, so we are mounting your data lake because your Snowflake is a cloud-based data warehouse. It's working on the cloud. So if you put the data into data lake, it can copy the data easily. And loading and unloading can be faster. The performance can be faster when you do it with the stage. Okay, so we'll see about how you can create stage, how you can mount, how you can do copy, unloading, everything we'll see.
Am I audible?
Yeah, you're audible.
I am asking what is stage and what do you define stage? I want to know that.
Okay, so in Snowflake, we are creating a table. So we are creating a table. So here I create only schema. I have CSV file. So I have a CSV file that has 10,000 records. Let us say it's 10,000 records, 10K records. So if I have to load the data into this table, so this data, it has like 4 columns. Let us say it has 4 columns. So I can create the table with the 4 columns. Okay, so this table, this CSV data, if I have to load it into Snowflake, I have to bring this data into stage. So it's a temporary area, it's a temporary space on data. So you are bringing the data into CSV data into your stage layer, then you will load it into Snowflake. Okay, if you have the CSV file in your local, you cannot copy directly to Snowflake. You have to bring it to stage. The stage can be external stage or internal stage. You have 2 stages, internal stage. So either I have to create internal stage or external stage. It's a temporary space. It's a temporary space. From there only you can copy the data into Snowflake table. Okay, so you cannot directly put the CSV data into your Snowflake table. You have to go through stage, copy it to stage and load it. That is how it can be done. So this is the fastest way of copying your data. Staging is nothing but a temporary space. It can be on data lake or it can be on local.
Thanks.
So this is again a staging is a data warehousing concept. In data warehousing, when you discuss about the legacy data warehouse concept also, staging is a temporary space. Before bringing the data into data warehouse, you bring the data into staging layer, then load it into data warehouse. That is a concept which is there in the data warehouse on like legacy data warehouse also. Okay. So I see another question. My AWS account, I'm not eligible for free tier. You can create a new email account, create a new email ID, new account, and try to go for free trial. Okay, if your old account is not working, use a new Gmail ID, new email ID, and create a new account. Use that free trial. Okay, any questions from anyone?
Just last question. Can you please go back to your PPT slide where you were showing the AWS architecture?
Yeah.
Yeah, this one. Now, my question is a follow-up question on that asset property. Now, if
Mhm.
in this case the data is coming from data source into using like Airflow or something into our data lake S3 bucket, and from S3 bucket it's getting loaded into Sage or Snowflake data warehouse. So
Mhm.
how will we ensure that the count of records are same? So let's say in data source there were 1,000 records. After ingestion tool started executing, it loaded the data into S3. Now S3 does not have asset characteristics, right? So how we will ensure that our final load into Snowflake is also 1000 records?
So we will do validations. So we will compare
Okay.
from the source, what is the data is coming, what is the count of that, and what in target, what is the count of that. So we will write a validation script and we will compare what is the source and what is the output. And why the missing data, why it is missing, we'll create a validation script and validate it.
Okay.
Okay, so your data warehouse is an analytical system. So it is meant for analytics. I can do fast analytics, but it doesn't have a lot of capabilities. Okay, so like it doesn't have a lot of capabilities. So you use different tools. You write some scripts, you use different tools, you bring in the capability for solving different problems. You use tools or you write some scripts and you solve the problem. So validation, data validation cannot be done in Snowflake. It is not natively there in Snowflake, but you will write a script and do the validation. You write some Python script or write a SQL script and you do the validation from source to target.
Understood. Okay.
Okay, any questions from anyone? So for the next class, before the next class, you have to create your Snowflake account. You have to create your Snowflake trial account. You have to create your AWS account. That are the main things. Other than that, for other thing like Airflow or DBT, all this installation we will see later. Okay, we will not do everything at once. For installation steps, I'll share a document. I'll explain what to be done. So we are going to use Docker. Okay, we are going to use Docker. I'll explain what is Docker, everything. For Airflow, for development, for faster development, we are going to run Airflow locally. Okay, so because if you can Airflow, you can run it on AWS also. Airflow is a orchestration tool. So I want to create my pipeline. I want to run it daily or weekly or hourly. Okay, I can create it in AWS. I can create it in Azure. So Airflow, you can create it in different places, but I'll be charged. Okay, you'll be charged for the services. So we want to avoid that. So I can install it in my local. Okay, I can do installation in my local. So we will use Docker and we will do installation. I'll explain about Airflow, how to do installation, everything. You will see it later. For now, you don't have to do Airflow or other steps. For now, create your Snowflake account. See if your Snowflake is working. So like once your Snowflake is created, like access the sample database. You will have access to sample database. You can go and check if you can see the tables. You can check if you are able to do data preview, write some simple SQLs. You can go to SQL, create a new SQL file. So you can see the sample database. So by default, you will get the access to sample database. So see if you can write SQL. So for example, so I'm writing SQL, running it. So I can run this SQL, see the output. So it has like 150,000 rows. So this is SF1. If I use SF10, the customer data, same customer data in the sample database. So in the sample database, you have different size here. So SF1, SF10, SF100, scaling factor, scaling of 10, you have different size here. So if you see, I'm running this query, it's running on my warehouse. So by default, you get warehouse. So when you create a trial account, you get a warehouse. So you get a small warehouse and that is started automatically. Okay, so you can start using it, get used to Snowflake web UI, how to write SQL, simple SQL on Snowflake, how you can start using all this thing. You understand the basic ones. That is what you can start doing it from this week. Make sure you are able to use this Snow site. You go through like the Snowflake sample data, run some SQLs, see the data here. So you can see first I loaded 150,000 record. Now it is 1.5 million record. You can see now, I'll go for SF100 or SF1000. Okay, run this query, see how it works. Or here you have option of AI suggestion. Okay, so you can see here AI suggestion, which you can tell write some complex queries. You can talk to your AI and build queries here. We will discuss about this later. For now, start working on the SQL editors, Snowflake workspace. This we call it a Snowflake workspace, and start using Snowsite. Starts to using Snowsite. Like we will discuss about this. So what is this? How you can use this? What is warehouse? We will start discussing about every component here. But for this week, create your Snowflake account. Try to run some simple query and understand. That is what will be a task for you. So you can practice this one. Okay, I see another questions. Does Snowflake support TSQL, PLSQL? Snowflake doesn't support TSQL. It doesn't support PLSQL. You have to write different logics to it. So you have to convert that, write different scripts for that. Okay, so you can like convert into procedures, or you can convert into different scripts, convert your TSQL to different scripts. You do a conversion. So if you are converting from SQL server, so we will discuss about migrations. When you are working on migration from old legacy systems, how you do migrations, we will discuss about that. So in that time, I'll explain you how you can convert your TSQL, PLSQL to different Snowflake scripts. We'll discuss about that. But Snowflake doesn't support TSQL or PLSQL. It supports procedures. You have procedures here. You can write procedures. You can write Python scripts. So you can solve the problem using procedures or Python scripts. All your TLSQL or PLSQL. Okay, any questions from anyone?
Well, I have one question.
Yeah.
When we are creating an account Snowflake, we use Enterprise and AWS, right? So,
Yeah.
and then after the injection into the Snowflake, like it is a database, as you said. So the data is actually stored in this AWS.
Yeah. So if you see here, you can see I'm running a trial version of Snowflake. I'm using AWS. Okay, I'm using AWS. You can see view account details. So my Snowflake is tied up to this AWS account. So this is my AWS account. So this account name you can see. So this it's a as we discussed, Snowflake is a cloud-based data warehouse. It works top of cloud. So here, this data whatever I stored is stored on AWS. Okay, so Snowflake has 3 layers. In the next week, we are going to discuss about architecture. So in the architecture, we'll understand this deeper. But to short, it stores in the data lake. Your data is permanently stored in the data lake. That data lake bucket is proprietary of Snowflake. Okay, so we will not able to see where they are storing, what format of this they are storing, but it is they are using a data lake and storing within data lake.
So in general, like the data will be stored in the either the Azure or AWS. Then when we are extracting it from the Snowflake, writing the queries, we are extracting it from their database.
Yeah, you see, so AWS account 1, let me say AWS account 1, Snowflake, AWS account 2. So if you see, you can see here, I have two AWS accounts. So I have two AWS accounts. So here I have S3. So here, I am using a free trial account. So the free trial account and that AWS account. So that is what this is. This is the account name. So this is my account. And my AWS account. So this is my account name. This is my account. So we have two AWS accounts. So we have two AWS account. So this Snowflake, when I create a table or create a database, It's storing here in this S3. Permanently, it's storing the data in this S3. So inside the data lake, they are storing it in some compressed form.
Do you mean Snowflake will not have a storage capacity of its own? It will use the storage capacity of the
Yeah,
cloud
cloud.
provider.
It provided
Okay.
the cloud. So Snowflake is going to use cloud provider and store the data in the cloud. So Snowflake has a 3 layers. We'll discuss about that later. But in S3, they're going to store your table metadata. So here we call it as metadata. So they have metadata and data. Both are getting saved. So they store the metadata also. They store the data also in your S3. And I have my own data. I have my some data, customer data. So to access this data, I have to create a stage and add this data. So add this. So then I can access my external data. This will become external data. This will become internal data. So internal data also stored in S3. My external data is also in S3. So both are stored in data lake. Okay. But this data I can manage it. I can manage it. This is managed internally by Snowflake. So this I cannot manage. I cannot see it. What is the bucket? How they are storing? This is managed by Snowflake. This is a proprietary of them. They are managing it. So this you cannot see it, but you can know the conceptually how they are doing it. You can understand. So is it clear? So we will discuss about it. When you are going to discuss about architecture, we will discuss about this. So you need to understand the Snowflake architecture. Then you will get a good understanding about that. Okay, so in next week, we are going to discuss about Snowflake architecture. So Snowflake has a 3-layer architecture. In that cloud storage, so cloud storage is your S3. So here you can see data is permanently stored in cloud storage. Even though Snowflake is a one SaaS product, in the Snowflake, they use cloud services. They use storage as data lake as for permanent storage. And they use virtual machines. All these things are cloud providers property. Okay, so you will be charged if you are going to pay for Snowflake. You will pay for Snowflake also. You will pay for cloud also. Okay, we'll discuss about this next week. We'll discuss about Snowflake architecture. We'll discuss about storage. A lot about this.
Well, but just last question, just one thing. So I feel it's a like merry-go-round. So what is happening is from data source, Airflow is picking up the data, putting it into S3. From S3, it is going into staging. From staging again, it is going into Snowflake data warehouse. But at
Yeah,
the back end, that Snowflake data warehouse again is storing the data into S3 only. So why do we have
correct.
to go to this entire chain when the data was already available from data source to S3 at first place? Why do we need a staging layer again?
Here we are doing data modeling, right? So here the data is in different form, right? So data which is coming in there may have 1,000 columns or 100 columns. Let us say it has 100 columns, and the data is quality is less. The quality of data is less. So we are doing cleaning. You are transforming. You are so that is the purpose of data engineering, right? The data is very raw form. The raw form of data cannot be used directly by business. So you have to change the data into different forms. Then only it can be used by business. So data modeling is done, and you are creating a tables and you are storing in different forms. So in your Snowflake, you are storing in different structure. So that can be used for different problems.
Understood. Okay. Okay.
Okay, that is why data modeling is done in Snowflake. Your data is transformed using transformation techniques. Your data is transformed and stored.
Understood.
Okay, any questions from anyone? How can I load sample data into sample database in Snowflake script? So sample database, if that is not there, I'll tell you. I'll share how can load it. So when you are installing free trial, you will get an option for loading sample data. If you skip that step, you can create like this. Okay, so you can see here. So this link I'll share it. So if you don't have the sample database, like if you don't see this, the Snowflake sample data, for creating that, you can follow these 2 lines of command. With these 2 lines of command, will create you the sample database. Okay, so this link I'll share it. So these 2 lines will import the sample data from their data share. Okay, and then we'll create in your local environment. These 2 lines of command is enough to load your sample data. Okay, so last thing is you also need to learn little bit on Python. Okay, so you need to have little bit on basic knowledge on Python. So if you don't know, you start practicing on basics about Python. So you need to know how to use variable, how to write some simple. Why we need Python? First, why we need Python here? Because we are working on a centralized data problem. So we are working for organization centralized data problem. So sometimes you may have to do some automations, or sometimes you may have to do some kind of validation script or visualization script. So for automation, for visualization, or working on data pipelines, you use Python. You don't need to write algorithms. You don't need to have a, you're not a Python. You don't need to be a Python program. Okay, you need to have some basic Python skill. So you need to write some basic, like how to use data types, how to write some conditional logics, how to use functions, how to write functions. This will help us when you are going to work on Airflow. This is going to help us. Okay, so Airflow is completely on Python. So this will help us to build a workflow, write some basic Python code. So start practicing on Python. So have some basic knowledge on Python. So even though you are a data analyst, even though you are a Snowflake developer or Snowflake data engineer, you should have some basic knowledge on Python. Because in the current scenario, in all the organization, they want you to write some basic script. They don't want to write some algorithms, complex data structures. You don't want to write all this thing. Some basic Python program you need to know. So for that, you start writing some basic script, like functions, how to write Python functions. So you try to practice on that. So that will help us when we learn into Airflow, when we learn into a lot of automation, scripting, it's going to help us. Snowflake edition, what edition we want to use? We are going to use enterprise edition. I'll talk about different type of editions. Like let me bring that here. So we will discuss about the different Snowflake versions in the next session. But we are going to use enterprise edition here. So you can select for enterprise edition. We will see about each editions, right? Different editions, what it is. We will discuss about the future later. Not now, because if I'm going to tell now, you will not understand a lot of things. If I'm going to tell you about cloning, if I'm going to tell about versioning, backup mechanism, all this thing, right? That will not help us now. So I will discuss about the editions. For now, you are going to select enterprise edition, work on the enterprise edition. Okay, Notion link I'll be sharing. So all the contents I'll be sharing. I'll share that URL. Use that. Okay, so all the day one, whatever the Notion I'm sharing it here, the content will be shared. I'll share the URL and the recording also will be shared. And the recording will be shared. So you will get, after few classes, you will get access to the our knowledge portal. So for the Education Eclipse knowledge portal, you will get access to this after 3 or 4 classes. Till that, I will share the videos. I will share the resources on the WhatsApp itself. Okay. So for the next class, you should create your trial version, Snowflake. You should create your cloud account. It can be with a different email ID. Your AWS account can be with a different email ID. Snowflake can be with a different email ID. Okay, any questions from anyone? Okay, we will stop it here. We will stop it for today. We will connect again on next week, Saturday. So if you have issues on trial account, or if you have issues on AWS account creation, you can reach me out in WhatsApp. And also, if you have any questions on creating Snowflake trial account, you can reach me on WhatsApp. Okay. So we'll discuss again on the architecture about different Snowflake basics in the next session. Okay. So we'll stop it here. We'll connect again Saturday next week. Thanks, everyone. We'll connect again next week.
Thank you.
Thanks. Thank you.
Thanks everyone. Thank you. Bye.
Thanks, everyone. Bye.